So thanks for going along on this journey with me, which is appropriate because we'll be talking about the customer journey and how to use graphs to unlock that. Very specifically, going over how to define the customer journey, which is rather simplistic, but at the same time can be quite complex. So it's always good to ground ourselves as I have this conversation with others, just so we're talking about the same thing. Um, Talk about the graphs, like what does a customer journey graph look like? What are some decisions you can make on how to architect that? Some insights you can gather from it. And then finally, getting more into an ML side of things, which is all around user journey embeddings and some of the graph data science algorithms that you could employ to achieve that. Um, Alejandro, potentially, if they're not, then email me and I'll send them over to you. Well, I'm pretty sure there will be. If you didn't know by the up next, I'm Jacob H. Marquez. I now work at Dahlia Labs. A lot of this work was done at my alma mater in terms of professional career thus far, which is Microsoft. I won't be sharing any product secrets or anything around Microsoft data. So, and I'm not a representative of Microsoft, but we will be focusing mainly on a generic view of customer journey, the graph, and user journey embeddings. If you have any questions, paste them in the chat. If I don't get a chance to answer them, follow up with me. I'm more than happy to have a conversation or to answer anything. Okay. I announce who I am. So I'm going to slide past this slide. All right. So as we talk about the customer journey, as mentioned, it's always good to define that. So let's just quickly go through that, right? A common definition, I think this one's from Gartner actually, is just the end-to-end experience for a customer, right? But when we're talking about diving into the journey, extracting insights, and even creating a graph from it, the end-to-end experience is the key part there. The customer is also key, but from a journey perspective, we're going to focus on that, the experience part. And really, what we mean there is it's a sequential amount of steps or interactions that are made by the customer. There are also steps or interactions not made by the customer. Maybe it's made by the company. As a customer does something, it kicks off a process. You could include those within the graph as well. But here we're talking directly actions made by the customer. So that could include a lot of things today. Last time I counted, it was at least 15, if not more, different channels of interaction, such as web, product usage, marketing, email, sales, support, just to name six, right? But there's a lot more that potentially your company has that a customer can interact with. So what does that exactly look like? So here's an example. We have Sally here. Sally is a unknown customer, but she's going to go through a series of steps, right? She's going to go to a website, sign up for a trial, use it a couple times, maybe talk to a support or a salesperson, and then convert to a paying customer, right? So a series of steps that she went through to come to this point where she is a customer. So that's a journey that a potential customer goes through. If you look at that really closely, maybe squint a little bit, clean off your glasses. I'm not wearing mine today, so I have to squint. Um, it kind of looks like a graph, right? Now, specifically, it's a directed graph, a digraph, or a DAG, if you want to use that terminology as well, because everything kind of follows a particular direction. But at the end of the day, it's a graph, and we can start thinking about the journey in that sense as well, and start using particular methodologies specific to graphs. So going back to the definition one final time, we're talking about the sequential steps a customer takes towards a product or towards a growth milestone within a product. And growth milestones really fall within three buckets. We're talking about acquisition, conversion, or expansion. Within expansion, you can talk about churn as well. But for me, that's almost anti-expansion. So I roll it into that third bucket. But this is kind of how I look at growth milestones within that customer journey. All right. Moving on, that was a quick overview. It's not meant to be a deep dive by any means, but if you have questions, feel free to let me know. But let's talk about the actual graph now. And this is going to be the core of everything that we build on top of that we can do, insights, algorithms, embeddings, what have you. So it's important to get this piece right because without it, you won't be able to do any of those things. I do want to note that the initial graph was definitely modeled after this patient journey graph by Neo4j in the developer blog. So I highly recommend taking a look at that because there is a lot of great concepts that I don't particularly include, but could be relevant to your area, your customers, or your business. Um, so super helpful. Before moving on, I do want to answer this question because I receive it quite a bit, especially when you're coming from a very traditional relational database sort of framework or system. And that is, couldn't you do all of this without a graph? My answer to that is, yeah, you probably could. And I've seen it done for years. The team I was on did customer journey analytics and data science. That was kind of their bread and butter, and yeah, they did it for 5 years. But there is this, trade-off that you have in terms of efficiency. How dynamic can you be with the questions that you're asking and trying to get answers for? And a graph is very well suited to achieve both of those things, especially at a hyper scale. Once you start talking about um, a lot of data, billions of nodes, very a lot of different combinations of customer journeys and what have you. So graph is very flexible and adaptive. Has a very, it's very fast. It's very agile, especially as we start talking about, multi-step journeys. That's multi-hops within the graph, and a graph is known to be very efficient in terms of multi-hop queries, right? Compared to a relational database where you'll need a ton of joins to achieve the same thing. There's obviously the graph science ecosystem. When we're talking about Neo4j, it's built in. You do have to pay for it, but it's there, super convenient. It's all done for you versus having to create your own algorithms. And you can extract new information about connections that you wouldn't get from relational tables, right? It's the structure of the graph that can provide more information. We'll get to that when we talk about embeddings, because that's a key part of that. So important graph structure is directed versus undirected. So a node and another node have a relationship that goes one way versus undirected. It doesn't have a way that it goes. It can go both ways. Monopartite and k-partite. So you have one type of node versus two or more type of nodes. And then finally, you have unweighted versus weighted. So unweighted, there isn't any weight or magnitude to a relationship. It is all the same. Typically, it's going to be one or something like that. Versus weighted, you have some sort of magnitude weight to a relationship. And that is important as we start talking about node similarity, which is important to the user journey embeddings. But I like to go over this because it's some of the core concepts of a graph structure that we'll need as we start talking about some of the other things. All right, so what does this base customer journey graph data model look like? Well, obviously, it starts with the user. The user is going to have some information. Here's a subset of the properties that you could include. A user ID, always important. And then there's a first usage date, which is important because it's a property that can be called quite often. So to have it on the node makes that query just a little bit faster. Every user is active on a particular day, and that day will be a day of activity within a product, within a service, within a campaign, on a website, whatever you want it to be. It's just this relative day that an event happened. You can also have a secondary relationship called first. So it's easy for you to say, give me all the users in their first day. The other way you can query that is through some of the properties on that relative day, which is the number property, right? So a day number of 0 is the first day a user was active within a particular product or app or website. Day 1 is the second day they were active. Now, it could have been the very next day, or it could have been 5 days from that first day, right? But the relative number is important, but you can also have session number and then date as well. So different ways to look at the same thing, but give you a different piece of information about how this user is using the product. Each day will have a next relationship to the successive day. And that's important for the journey aspect, right? Because we want to start saying, okay, give me day zero, and then give me the next day, and then give me the next day, and start traversing that chain of events or the chain of relative days. Um, but the important thing here too is you could start at, well, give me day 30, because that's when they purchased the trial or they purchased the product, right? And then give me all the sequential days. And this is a nice part of the graph is the window can shift very easily um, to answer a different question. On each day, there's an event that happened. Um, and that's important as we start understanding the DNA of a customer journey, what's it made of. Um, and then there's the name of the event and how often that happened. Count here is on the event node, but in this particular case, it's on the relationship type. Now there's a dotted line here because this is almost a ghost relationship. It's only used for the embeddings, which we'll go over, but it's important because it builds that connection or sort of a traversal path that you can start understanding how users are similar to each other versus without it. If you had two users, you wouldn't be able to say, well, they had a similar event, that ties them together in some way and they become similar in that way. But with it, you can start making those sort of connections and calculations. If you want to learn more, I wrote a lot more detail about all of this that I'll be going over on Medium. You can go check it out. Just search for my name. And there's links in the PowerPoint. If you want the PowerPoint, I'm happy to send it to you. So what does that actually look like in practice? I mean, we looked at a diagram, right? It was potentially somewhat comprehensive or something that you could comprehend, but it's always helpful to see a visual in an actual customer example. And again, there isn't any specific Microsoft data here. So you have a user, the user bought two products, product A on the left side and product B on the right side. There were particular days in which they bought those products. Um, and on the left side, it's negative 113. And then on the right side, it's 77. And those numbers are relative to the first day they were active within the product. So the first day they were active is day zero. So 113 days before that, they purchased product A. 77 days after that, they purchased product B, which in this case is the product that they are active in. And there's all these other days that that user had activity, did particular things, explored the product, built something, shared it, or what have you. Um, so we can have all of that information in the palm of our hands for us to start sort of playing with, almost like Play-Doh or like a DNA sequence, right? And the sequence is important because that's where we start talking about the journey and what is it made of and how are they moving through the product at what velocity, um, and and yeah, how, what, when. I guess those are three very important questions. You could have where as well if you wanted to add something about like browser type, device type, stuff like that. That's up for you to decide. Now, on that sequence, as mentioned, we have all the activity that happened on those particular days. And in this view, the size of the node, the purple nodes, the activity event nodes, indicates the amount of times that event happened on that day, right? So you can see here that the user was particularly active early on in the journey. And this is only looking at day zero through day 77. So when they first started to when they purchased. Um, the activity remained consistent, but they weren't as active. So you could say the first couple of days they were active in exploring the product and becoming acquainted with it, maybe building something. And then the following days, maybe they were sort of optimizing it, making it more efficient, or just doing very particular tasks once they became acquainted with it. But one user journey on their own isn't really interesting. I mean, it's mildly interesting. It looks cool, but the power comes in comparing user journeys, right? Especially as you build cohorts of users that you want to understand the differences between. And in this particular case, it's users that purchased and users that didn't. And when we're talking about users that didn't, you'll have to have some sort of time frame to limit yourself to. That could be, okay, show me the differences in the first 7 days or the first 30 days. And again, the window and the how dynamic the graph can be is super helpful here because you can, start with one and then figure out, okay, week one was interesting. Okay, what about week two? And you can just continue to move that very easily and quickly and get more and more insights. So, as an example of insights that you can derive from this, I'm going to show a couple, right? So, we had a user and we know that they purchased this product A, or at least those are the users that we're going to focus on. One first thing that you can understand is what's the average time it takes to purchase that product, right? And for one particular project I worked on, we found it was 90 days, right? As an example. But what we also found is really the first 7 days are the most important in terms of purchasing that product, right? And again, if we go back to what we just saw, they were super active the first week, and then the activity kind of decreased. It didn't die, but it decreased, right? But the first 7 days are super important. So let's just look at that for a quick second and get an idea of some of the insights that you could easily derive. I hope you like my animations. So if we look at each day, so we have 7 orange nodes, 7 day nodes. We found that on the first day, super important, if they do event A, and again, I'm being very generic here, but we did find a very real situation of this, they're 1.5 times more likely to purchase the product, right? Which is super interesting because you can start building hypotheses and experiments just on that piece of information alone, right? Let's go build a marketing campaign or some sort of in-product notification experiment to see, can we get more people to do event A because we know it's likely going to lead to an ROI. But what we also found is if we start looking at sort of this market basket of days and events, right, or this sequence of days and events, if they do A and then B the next day, they're 3 times more likely to purchase the product, right? So it's not just now we're not even just looking at one single event. We're understanding what's the combination of events that lead to an optimal sort of outcome for the customer because they're becoming more acquainted, and for us because we're making revenue, right, as a business. Um, and so, um, yeah, again, you can build campaigns and experiments off of this. Now, conversely, it's not only about what leads to success, it's also about what doesn't lead to success. Like, what are some of the friction points that are happening within the product that we can easily start looking at? So, here was somewhat interesting. There was this event that was occurring pretty frequently. 60 to 70% of users did this interaction on the first day. But what we found is if they did that, 0% chance of purchase. It's a helpful feature to have, and people were using it, obviously, but there wasn't any sort of conversion path or next step for users to take. And this is a huge opportunity, right? Because if we could get them to come back and do that event A step on the second day, we have a proportion of our user base that wasn't converting before that is now potentially converting. Um, so, uh, again, the way that you can slice and dice the data, you can do it very efficiently and run experiments and insights very quickly to get new pieces of information. All right, 4 minutes left to go. I can get through this and not sounding like a chipmunk. All right, so All of what we talked about thus far is more on an analytics, potentially building experiments perspective. Um, it's slice and dicing the data, business intelligence sort of focused, what have you, but doing it at a scale that you can move very quickly. But the question became like, how do we scale that even more? We can't look through all possible journeys, and we have all these questions that we want to answer. So how do we build some sort of methodology that allows us to say, this is the user journey. This takes everything into context. This is the user journey, and these are how the journeys compare across different groups, across other users, what have you. And that's where this concept of the user journey similarity came into play. And the idea is that users are similar based on which days they're active, what they're doing on those days, how much they're doing those activities, and when this occurs within the journey. You could also have a absolute date when perspective as well, but the which, what, how, and when are super important. So the basic idea is we have this graph. We have user, the day they were active in the event, and how much it happened. And we have all the other users as well in their activity. So if we only focus on the day in the event nodes for right now, um, we can start looking at node similarity. And I guess I should mention this before. There's two steps to this. There's the node similarity, so understanding which days are similar, and then there's a user embedding, and that's understanding which, or it's building vector representations, numerical representations of users based on their day similarity. Um, it's very similar if you've ever done natural language processing in text embeddings or word embeddings. Very similar concept, but here you're doing node embeddings essentially. Um, so if we look at these two groups of users, we have the nodes on the right side and the days on the days on the left side and days on the right side. The days on the left are all very similar because they're all connected to the same event type. And conversely, for the days on the right, they're all similar because they're connected to the same event type. Um, Now, day two on the left is a tad bit lighter because it's day two, whereas all the other nodes are day one. And again, we're taking into context when it happened, just as much as we're taking into context what happened. But we also want to take into context how often it happened. And once we add that, we can see that day one becomes a little bit lighter as well, um, because the volume in which it happened was less. Um, and then we can draw these similar to relationships between days. Now, for the sake of time, because I have 45 seconds, I'm not going to go over the math, but it uses node similarity from the GDS algorithms. And we can see that most days are similar, which is not helpful. So what we want to do is update the node similarity with two factors, which are just decay factors around relatively when did it happen in the session number. And here's some math. Again, if you're interested, I can share it out. And what we see is we're slowly improving this distribution, which means we can start experimenting and building models off of it. You may want to take some more time to optimize it, but at least it's the starting place because we have some variety that occurred. And I think I just hit time. I don't know if it's going to kick me out or not. 5 minutes remaining. Wrap it up. Okay, Clark, I will wrap it up. Um, So I didn't get to go over the rest of it, but essentially, as mentioned, it takes into account um, these node similarities, starts building embeddings with FastRP. So now we're building embeddings for the users based on the similarity of the days. And then ultimately, we'll be able to do things such as cluster analysis and predicting an outcome. Here's an example of clustering based on the embeddings. We identified 4 cohorts and saw that one was highly different. The activity that happened in that cohort was very different. So we can start making assumptions on what types of users those are. In building classification models with these embeddings from the graph, it performs quite well and exceeds what we were able to do from hand featured engineering. So highly recommend looking at this. That's my time. Thank you very much for joining. If you have any questions, feel free to reach out. There's my email, jacobhmarquez@gmail, or find me on LinkedIn. Thank you very much. Enjoy the rest of the nodes.